Jawohl, los geht's. Hallo zusammen und herzlich willkommen zum nächsten ika-Meetup Automated Driving. Bitte nicht wundern, ich wechsle jetzt sofort die Sprache ins Englische, weil unser Gast heute auch seinen Vortrag auf Englisch halten wird. Wir können, glaube ich, später sogar auch die Diskussionen teilweise in Englisch, teilweise in Deutsch führen, je nachdem, wie es passt. Aber wir halten es jetzt erstmal einheitlich, um mit dem Vortrag zusammen in einer Sprache zu bleiben. So, welcome everybody to today's ika-Meetup Automated Driving. I'm very happy to have you all here, and I'm very happy to present a very interesting topic to you today. And today is all about perception, and perception especially with LiDAR sensors or laser scanners. In the last meetups, you may all have got some information on radar, on camera. We haven't talked about LiDAR that much, and we are going to change this today with our guest, Dr. Roman Katz. I'm very happy to have you here, Roman. Thank you for joining us. And today, Roman, he is with Ouster. Ouster is a LiDAR manufacturer. We will tell you more about that, I guess. And Roman is going to introduce us to his topic, Superpowers for AD systems, 3D high-performance LiDAR sensors for automated driving. As I mentioned, Robert is with Ouster. He's Business Development Director, Automotive and EMEA at Ouster. And yeah, I'm very happy to have you here and yeah, to hear some words from you. But first, as always, let's give a shout out to our sponsor today, FKA. As always, thank you for supporting the ika-Meetup and hosting this digital event today. Maybe next year we will have the chance to see us all in person again at the Institute. A little outlook to what is going to happen in this year. Today is the last presentation of the automated driving part of the ika-Meetup. But there is one more presentation in December with the electromobility session where Dr. Jan-Philipp Schmidt-Ewig is going to introduce you to the battery electric drivetrains for automated container transport, which is, I guess, a very interesting topic as well. So I guess save the date for this presentation. If you have any questions on today's presentation, you can, as always, use the chat function within GoTo, but you can use Slido as well. Just type in Slido at your browser, and put in the meeting code, which is hashtag meetup 1911. And you can ask your questions there. I will later on then try to moderate a question session, but I guess with that many partners here today, we can have a little discussion in video as well. So that's it from my side. Thank you all for being here. Thank you, Roman. And yeah, I'm very excited to hear your presentation.
Cool. Can you guys hear me?
Yes, we can.
Okay, perfect. Excellent. Thank you, Timo, for the intro. Hi, everyone. Good to be here. It's funny to make a presentation at a meetup, to be honest. I haven't done that before, so let's see how it goes. So I think I'm sharing already. Yeah. All right. So okay. So let's start. So yeah, as Timo was saying, my name is Roman Katz. I'm glad to be here. Trying to move away a little bit from a standard sales pitch. I've been asked to try to avoid, giving you like a standard sales pitch. So it's been a little bit of special work for this presentation. to be honest. But yeah, I hope it's interesting for you guys. So yeah, I'm with Ouster. I do business development, as Timo was saying. I'm part of the European team. So Ouster is a company from San Francisco, and we have a team here in Europe. I'm located in Germany, in Hamburg. We have another colleague in the south of Germany, and a few others in Paris. So we mostly do in Europe. We do mostly sales and support, and there's a little bit of background noise. So maybe I don't know if everyone is muted. That would be good to do that. All right. So it's better now. So yeah, I was saying, so I do business development for automotive customers, mostly Tier 1s and OEMs, but also some other companies, smaller startups, and shuttle buses, and some other customers out there. And yeah, I'll be talking about 3D high performance lidars for automated driving, and aka Superpowers for AD system. So the guys from the meetup pushed me to come up with a more kind of a little bit more sexy title for this presentation. Yeah. So what we do is, first of all, at Ouster, and I promise I'm gonna move very quickly through my standard sales slides, and then I'll dig into the core of the presentation. So at Ouster we do lidars, high resolution 3D lidars, as you can see here on this slide. At the bottom you see typical view, Cartesian point cloud view, or coming from one of our sensors. In this case, the OS1 128. OS1 is one of the mid-range sensor that we have in our product portfolio, and the 128 basically denotes the number of layers that we have for that one specific sensor. We have different variants. I'll quickly go through the product portfolio in a minute, but just so that you can understand what you are seeing right now. So yeah, at the bottom, typical, very kind of standard view of the LiDAR data. As you see, high resolution, very a high level of detail type of data that we get out of our LiDARs. At the top, you see two more images, and let's start with the middle one, that it's called signal. So signal, it's basically the amount of energy coming back into the sensor after you hit the objects. So there's some amount of light of information coming back into the sensor, and we measure this, and we call this signal. And the amount of light that goes back into the sensor is obviously correlated with the reflectivity properties of the material that you hit with the laser beams. And different vendors have different names for these. They call it intensity, reflectivity. We call that signal. I would say it's kind of typical that meaning you pretty much get a signal, so some sort of related or connected data to the signal in all the LiDARs out there. So nothing new here. What's interesting, I would say, or special, is the top one, which is called from us the so-called ambient images. And even though they are kind of similar, the top image to the one below that one, they are not exactly the same. As you can see here on the ambient, you see, for instance, the shades from objects, from trees, from cars. You even get to see the clouds sometimes. So it's actually a different type of data. And this is indeed the illumination that we have in the image, in the environment. We call that ambient. So it's essentially what you would get if you had, let's say, grayscale camera in the system. But in this case, and to be clear, there's no additional cameras. So it's not it's not that we have integrated an additional camera chip or CCD chip or anything like that inside the sensor, but instead all this ambient data comes directly out of the same detector chip that we use to measure the range. And this is, I would say, one among many of the interesting features that we have in our lidars, that we are able to give you directly these camera-like images. And as you can imagine, you can do image processing if you're working with machine learning, kind of, that typically or very often use kind of images to feed into some sort of neural networks and so on. You can directly use these kind of images to combine and to fuse with whatever kind of point cloud-based processing you're doing, without having to install additional cameras into your setup, into your vehicle. So let me move on. So yeah, there are lidar companies. There are many companies out there, many people developing lidars. So I think it's important to kind of give you a little bit of context of the type of customers we are working with, right? So why are customers working with Ouster lidars? And I would say there are multiple reasons, and that I try to summarize here. So people or customers come to us when they want to have the highest resolution possible for their perception, when they are a little bit frustrated that they have to pay often a lot, way too much to get high resolution point clouds, very often because they are kind of tired of using unreliable analog old school APD based lidars that break very often, when they are looking for something small, lightweight, and easy to integrate, good form factor that they can really integrate into their vehicle, even small robots, small drones, and so on, which is happening indeed with our lidars. And when they are using machine learning within their perception pipeline, because our sensors, as I'll explain in a second, they have some very interesting capabilities and features that are interesting if you are working with machine learning kind of approaches for your perception. And yeah, so we indeed help these customers, and here you can see one of our lidars on the left. We help indeed these type of customers coming to us because we have the highest resolution available in the market, still have affordable sensors, especially if you go towards the highest end, towards higher resolution. Our digital architecture that we have in our sensors basically allows us to have very reliable and rugged sensors because of the field of view. So our sensors are spinning, so there are actually some advantages of having spinning, like 360 degrees of horizontal field of view. We all have, and I'll show very briefly our portfolio in a second, but we have different sensors covering different vertical field of views as well. So we can definitely address different needs. We have the smallest form factor for this kind of resolution, high resolution sensors in the market. As I mentioned before, and I even showed in the video in the beginning, we deliver this ambient data that can replace some additional cameras if you need this type of data. Our sensors deliver or give you structure point cloud, meaning that you always know for sure, and you get a very, very regular grids or information that you can represent as grids, which is super useful when you're doing labeling or when you are feeding that into GPUs, because you can really make sure that you can structure point clouds as regular 2D arrays. which is indeed super important for machine learning. And all our sensors have an internal IMU embedded in the sensor itself. So that's obviously a nice feature if you are kind of going in the direction of doing, ego motion estimation on SLAM, because you can directly use the IMU, the internal IMU for your processing. And I promise this is the last sales slide that I have today. So this is essentially the product portfolio that we have, that, by the way, that you can buy off the shelf from us today. I mean, it's not that we have some concepts or, that it's going to be like future sensors, like, sometimes that happens in the LiDAR domain. These are products that you can buy from us today. And we have in our portfolio the OS1, which is an ultra wide view sensor, meaning we have 90 degrees of vertical field of view, which is super useful and interesting for short range, though. There's always a little bit of a compromise between vertical field of view and the range. And it's super useful and interesting for low speed applications, blind spot monitoring, and these kind of or very large vehicles like trucks or buses, where you are where you need to mount the sensors very high up, but you still want to cover, and reduce the blind spots that you might have around the vehicle, for instance. So this is where we are seeing the OS0 actually helping customers. The OS1, I would say this is like an all-rounder sensor. So it's mid-range, so a slightly smaller vertical field of view, but longer range. And here the applications are, something in between. So since you have a longer range, you can do like things towards localization or obstacle detection. Still, the vertical field of view is kind of reasonably large, so you can still use that for monitoring around large vehicles. Let's say something in between, and I would say autonomous driving, robots. These are the kind of target use cases or applications that we're seeing for the OS1. And the OS2, it's our long-range sensor. So here we get to see up to 140 meters. The vertical field of view is narrower. So here the applications are mostly towards automotive because of the range. You can imagine things like obstacle detection on highway, higher speeds may involve, the need to detect the objects further away, and therefore you need the range, right? So these are I would say the type of target applications that we see for the OS2. So let's say we think we have an interesting portfolio of sensors that cover, I would say, pretty much all or most of the use cases that our customers have at the moment in terms of perception. And we are indeed seeing that with our customers, right? So, so we have, important to mention, not only automotive customers, but the other segments and markets as well, right? So we have, of course, many automotive customers, trucks, buses, advanced concepts, racing vehicles, validation programs, and so on. But we also have things like robots, robotics, that's very strong market for us. We have surveillance, we have things like drones, because of the form factor and the weight of our sensors, you can mount them on drones. So as you can see, and there are other, monitoring and some other, like more crazy projects. I think that the main message here is that we have many customers across different markets, and which is actually very, very exciting, very interesting. I think for today, I would say that the focus is definitely more automotive. And we have indeed many customers in automotive. And this is indeed what's going to be, let's say, my focus of the presentation. So I'm going to be talking today about what I call the key pillars for autonomous driving. And we can argue, that there are probably many topics and many pillars for doing that. But in my opinion, these three topics are fundamental to achieve autonomous driving. And these are advanced concepts, validation systems, and infrastructure-based perception. And so advanced concepts, as you can imagine, we are talking here about proof of concepts, R&D initiatives like racing vehicles or autonomous buses or some other prototypes and autonomous trucks and so on. Whereas you see every day in the news, LiDAR it's a fundamental part of the perception. Not the only one, but a very important part and a very important sense of to achieve to realize the perception for these advanced concepts. And I'll be talking and I'll be showing some examples of some of the work we are doing, mostly together with partners. With respect to advanced concepts, I will show you some examples on this in this presentation. The second pillar is validation systems, and here again, LiDAR is validation systems, meaning systems that the customers use to test and validate the performance of some other perception layers. And as you can imagine, LiDAR, because of resolution, because of the accuracy, because of the level of detail, is a very important sensor, which is indeed very often used within validation systems as reference sensor. And I'll show you some examples and some of the topics we are working on. Again, also here through some of our partners and friends within the validation systems, let's say, market. And the third pillar for autonomous driving is what I call infrastructure-based perception. And this is actually a little bit different from the other two in the sense that here we're talking about sensors that are static, somehow fixed in the infrastructure. They're not, moving around and being driven on vehicles or platforms that move around, but indeed, static and doing perception. And I'll be showing you some of the things that are happening with our lidars with respect to this segment, which it is indeed, it feels at a first glance a little bit off and a little bit different or completely unrelated from the other two, but it's actually tightly connected in the sense that if you are able to detect, track and classify objects, for instance, like here illustrated, and I'll go into this in a minute, but just as a preview, if you are able to perceive what's happening from these static lidars, you can indeed then broadcast this information to, for instance, autonomous vehicles that might be, driving around in this area. And this obviously can make use of this additional sensing capability, even without, being able to sense these objects or these vehicles by themselves with using their own local sensors. So we say that's the direct connection between infrastructure and advanced concepts, for instance. And we are also seeing that infrastructure-based perception is being used, for instance, as even within validation systems. Just to give you an example, for test tracks. So we are seeing that a little bit of a trend of test tracks installing, sensors in the infrastructure to use for doing the validation of the vehicles, the proof of concepts, or yeah, whatever the platforms that they have, you know, that they drive around in that test track. So there's definitely a connection here between these three pillars, and yeah, these are the things, the three topics that I'll be showing you today. Let's just as a preview, I'm going to be showing a lot of videos and pictures because I thought that was the let's say the most interesting way to illustrate these use cases and what's happening here. And I'll be showing you also quite a lot of material coming from partners and friends. So I'll make the proper introductions, but just as a if you are interested in any of the things that I'm showing, obviously at the end we can go a little bit more into detail, and I'll give you my details as well. So if there's something in particular that you think it's interesting for your work, yeah, we can discuss that at the end or offline, or you can always reach me afterwards, right? So let's then move to the first pillar, which is advanced concepts. So, and let's start here with something I thought it was kind of cool, and hopefully unexpected, which is a concept of an autonomous bus. This is from our partners from Adastec. So this is a company located in the States and in Turkey. That it's very interesting because they focus actually on the development of autonomous buses. And let me play that one again. You can see three lidars. Sorry, three lidars at the front, one on the roof, left, right, and a few lidars also at the back of the vehicle, there, and there. Important to notice here that they are using lidars, but not only lidars. So Adastec, they also combine radar, and they fuse camera data as well. But lidar is indeed a fundamental part of their processing, their perception stack, and they are mostly using them for obstacle detection and localization. And yeah, this work is mostly done with OS1s, which is kind of the all-rounder mid-range sensor that I introduced in the beginning. Second example that I want to show. Let me pause that for a second. So this is work from the ARK team, which is the autonomous racing grass team, connected to the TU grass in Austria. And they've been working with lidar, with our lidars for a long time, and they've been using recently our lidars in the context of the robo race. As you can see here, that's their vehicle. It's hard to see; it's a little bit too small. That's one of our lidars on the roof of the vehicle, and they've been using mostly OS1s to map the race tracks and to compute the maps a priori, and then they use those maps while driving again on the circuit for real-time online localization on the map. And the main motivation for them was that because of the speeds of the racing vehicle, they were not getting proper results with the IMU GPS systems that they were using. And in addition to that, they were struggling with like 3D, you know, like indeed have like proper pose estimation. The guys, the vehicles, they do accelerate and brake very, very suddenly. So this nodding of the vehicle, that was a little bit of a challenge for them to capture this 3D pose, and they were able to address that indeed by using 3D lidars for essentially for localizing on the pre-recorded map. By the way, there's a publication connected to this work. I can send you a link afterwards if you are interested into more like the scientific details of the development they've done here. Okay, so next example that I want to show you is a work we've been doing with our friends from Outside. So Outside, it's a French company. It's located in Paris, and they develop. They have a product which is called the Augmented LiDAR, which is essentially a computer that takes or is able to take data from our Ouster lidars and fuse that and process that to obtain to generate localization solution. And it might be a little bit hard to see, but there's actually a trace of points being shown in the animation in the video that basically illustrates the trajectory that this truck this vehicle is following. So this is an experiment project we've done with them, with their system, and with one OS2 lidar from us in a port domain. You might see some ships, some cranes, some containers. So this is indeed a kind of a rough industrial setup with big metallic structures that actually make the use of only GPS very, very tough. And we've been working with them, putting together this system, and did some very interesting experiments and projects. In this case, using this localization system from the Augmented LiDAR box together with a LiDAR for autonomous driving of this truck in the port. Maybe what's interesting as well is that we are seeing indeed some interest from customers with these type of systems to provide redundancy, meaning even though it might be that you can still work with GPS or with the standard GPS IMU system, sometimes for specific applications you might need some sort of redundancy, and this system that is actually kind of decoupled from the GPS IMU system might give you this additional source of information for localization, which is basically gives you this second level of redundancy, which is completely decoupled from the other one, for in case you need to achieve that. Anyways, I thought that was actually very cool, very interesting in terms of how to an interesting application of LiDAR for a system that actually helps in the development of automated vehicles and advanced concepts, for sure. Okay, so looking at the clock, all right, so we're good. So let's move on to the second pillar, which is validation systems. And just to give you hopefully a brief introduction to validation systems. So essentially here the problem is what the customer is looking for is a system to be able to validate the performance of their own sensor or perception layer. And very often this is called the DUT, which means device under test, which is illustrated here, which might be camera, radar, even another LiDAR, together with some software package that performs perception. And very often the challenge here, which is related to being able to validate a perception either for autonomous vehicles or for ADAS is how we can actually make sure that we have the target performance for that DUT. And the typical approach, not the only one, but very used one, is to have a reference sensor on the vehicle that you use to collect some additional information while you drive. You log all that data, and then obviously you drive around, and you know, like this type of validation actually involves quite some large amounts of data, a lot of kilometers, because it's normally at the end of the day ends up being a matter of, you know, statistics, whether you are missing objects, whether you are able to detect objects all the time, or, you know, within a given confidence rate. So basically you have to collect very often a lot of data. So logging is a critical part of the system. And again, there's a vehicle with reference, sensing, DUTs, logging, and you drive around. That's, let's say, the first stage of the validation. The second stage is, once you have that data, you want to extract, you want to process, first of all, the reference raw data to extract ground truth. There are different approaches to do that. Could be automatic, semi-automatic, could be some sort of manual labeling. Doesn't really matter. At the end of the day, the important message here is that you extract the truth, the reference, that you then use as your basis for comparison with the data that you have from your DUT, and you compute some KPIs. So long story short, at the end of the day, you have some KPIs, some metrics, and you can evaluate, you can tell whether your sensor with software has achieved the given performance. And as you can tell, this is a complex system and involves a bunch of different bits and pieces. And we've been working for quite some time now, putting together partnerships in place to basically address all or most of the components of this toolchain here, right? So, and this is what I want to show you today with respect to validation systems. And let me start obviously with what happens first, which is you need a car, you need a test vehicle with sensors, right? So obviously, very important is to be able to integrate the sensors in the vehicle, to calibrate them, and we are working with different companies. These are just examples, not the only ones. But for instance, with respect to integration and calibration, we are working a lot with Seymour. It's a German company that has quite some know-how with respect to putting together vehicles and being able to calibrate and cross-calibrate the sensors, as you can see here, for cross-calibration of Ouster, which are the red points, and Velodynes, which are orange points that you see here in these two images. So this is some interesting work that we are doing with them. As we've seen here, there's a component that has a logger, and this is also a critical thing especially for validation systems, because normally there's quite some data involved, quite a large number of sensors that you have on the vehicles. So you really need very robust logging systems. You don't want to miss, you don't want to skip frames, you need like proper time synchronization. So this is indeed a critical thing on the whole, puzzle. And we are working here with another German company, which is B+, that developed these high performance logging systems. And we've been working together with them, let's say, putting together the proper interfaces so that this is, by the way, a test vehicle from B+ with our sensors on this. And so basically all the interfaces are now in place so that you can pretty much, plug them in directly, and off you go. You can start collecting data for your validation directly. So this is actually cool work happening there with these guys. So to recap, that's everything up until now happening at this level of the vehicle. Now we're moving towards the second stage. Okay, once you have the data, what do you do with that, right? So, and here we have several partners that are working with us. One of them is another German company in this case. It's called Intenta. These guys are experts with respect to extracting ground truth, extracting objects and annotating data, LiDAR data. And this is a trace from one of our test vehicles in San Francisco. It's one OS1 on the roof of the car driving around the city. And by the way, only one sensor here. And you see all the different objects that have been annotated by Intenta. Yeah, they are able to attach a bunch of attributes to each of the object, and obviously classification, and they can extract obviously all the velocities, position, and everything that you need then to extract the metrics that you have in mind. So this is actually a very cool thing that we've been doing with these guys with respect to extraction of ground truth data out of LiDAR raw data. Okay, so let's move on now to the third pillar for AD, which is what I call the infrastructure-based perception. And yeah, again here, it's slightly different in the sense that the sensors are now fixed in the infrastructure. So here, this is a smart traffic light in China. You see one of our sensors up there. It's not the only one. There are also cameras and some other sensors. And this is, by the way, from people at the ika-Meetup. So they've been working in the context of the project HDV MES with our sensors. So they built up these sensing stations that contain each of these stations 2 lidars and I think a few cameras, and they can actually position in different locations. And then these are kind of self-contained units. There's a generator, there's a computer, and they are able to process data, extract some semantic information. Well, for instance, the dynamic objects, and they are able to broadcast to send that information to either a central unit gathering the information coming from different units, or even broadcast that to some other road users. And yeah, this is, I think, a nice segue to show this, since I have a cool video from them, where you can see this is, I think, indeed an intersection close or even maybe within the university campus, where they have installed 2 units, one over there and one here. And they are indeed, yeah, obviously all the points is the raw data, and the boxes, the 3 boxes, are the objects that they are able to extract and track out of the raw data, basically containing relevant dynamic objects that they detect in the environment. And again, you can imagine that if you had something like this, you really have, going back to the second title of the presentation, you really have superpowers in terms of you can very easily broadcast this information through V2X setups to other vehicles, and they can know in advance what's happening there and the exact position of other road participants. So it's indeed a really cool thing, and where we are, yeah, indeed seeing a lot of traction with our sensors. Also, and very relevant, especially in Europe, because of privacy issues, right? So as you can imagine, you might as well use other sensors like cameras, which is actually, by the way, kind of the historical sensor being used for these kind of applications. But there are obviously immediate concerns about privacy. I know I've shown that we have the ambient images in our sensors. That's, by the way, something that you can disable. And at the end of the day, you can, if you want, stick to only the range data, which gives you this additional, level of privacy, because obviously you're not going to be able to, at least not yet, run some algorithms to identify the faces or something like that, only based on range data, right? So this is actually a big plus, which is indeed one of the requirements that we are seeing, at least in projects happening in Europe with respect to these kind of applications. And another example here, you can imagine that once you are able to do perception from static units, you can think of obviously some other applications that are not directly related or linked to autonomous driving, but could be more towards, for instance, traffic monitoring or law enforcement kind of applications. And this is indeed what we are doing with a partner, IoT, that they have focused 100% on this kind of, traffic enforcement applications. And yeah, like I said, once you're able to track and classify, you can measure velocity, you can do, you can measure the speed of the vehicles and issue tickets. You can analyze what's happening with traffic. You can count vehicles. You can measure the density that you are having in certain roads, in certain lanes. So there's a bunch of different interesting applications. Like I said, not really AD, but anyways, very interesting, that are enabled, let's say, by having the chance of doing this kind of perception from infrastructure. Yeah, and here you can see some examples where they are actually measuring kind of density for different lanes in different directions, and obviously you can derive different metrics and statistics out of that data. So obviously, if you have something like this, it's a little bit of a challenge to do the deployment and to do the development. Meaning, if you're working with sensors on a vehicle that you have in your garage or in the workshop, you can always go and tweak the sensors, change the mounting position, change the pitch, or I don't know, put it higher, put it lower, and whatnot, right? So you can really you have a different level of it's very easy to actually play around with the sensor, with the mounting, and make sure that you are indeed covering the entire set of requirements that you might have for your perception. But when you have something that at the end of the day goes into traffic lights or poles or buildings that you cannot access all the time, so you can imagine that it is indeed a little bit of a challenge to be able to make sure that you're indeed covering all the requirements that you need for your perception to work and to cover, to address the use case, right? So that's why we've been working with Siemens in simulation, and what you can see here is simulated data out of their software. It's called Prescan, and this gives you this additional level, this flexibility, which is, like I said, critical for infrastructure because of this difficulty to access and to test, and so that you can really, make sure that you are covering all the requirements in terms of perception, in terms of coverage, in terms of density of points in given objects, in terms of the height. You have to make sure that you position the sensors in proper height and so on. So this is a very interesting work we've been doing with them. So we have incorporated a bunch of our sensors already in this tool, and I think it basically enables you or the users of these to play around, to put together these setups, these scenarios to help with the deployment, which is, like I said, super complicated or challenging, let's say, for infrastructure projects. Okay, so as I'm actually getting to the end of what I have prepared. So as a summary, I have presented what I call the pillars, three key pillars for automated driving, which are advanced concepts, validation systems, and infrastructure-based perception. Where we see that LiDAR is a super important sensor for addressing the perception needs that you have in all of them. Of course, not the only one, but a very important one. And yeah, I've shown you a bunch of examples, and I think a few interesting and cool videos and from real applications that we are seeing with customers and with partners today. And yeah, so that's actually what I have prepared. Thank you very much for your attention.